Hello everyone. So in the previous video we just discussed what the basic outline for this course is going to be. So this was the outline we discussed, and one of the first topics we have is the need, understanding the need for dynamic arrays here. So why do we need dynamic arrays? Firstly, what even is a dynamic array? So if I try to put it into the simplest words possible, a dynamic array is an array that will grow in size as you input elements into it. So first, before understanding what a dynamic array is, you would have to understand what a static array is. Static arrays. So static arrays are arrays that you predefine in your program to have a certain length, like let's say 5. So you predefine your array to have this length. So let's just not take any pseudocode or actual code for any type of programming language. Let's just try to visualize it. So if I'm creating an array that can hold 5 elements in it, we can visualize it in this sort of way, that we have something that has 5 different compartments in it. Each element will be stored in each of these compartments. So suppose I am storing numbers 1 to 5 in my static array. They go in this manner, right? And voila, a static array is created and is filled. But what if we need to add another element, or another after that, or another, or 1,000 more elements? We can't do that here, can we? Because we only have 5 compartments here. 5 compartments. To add a sixth element or a seventh element, we need a sixth compartment here. Only then we can add this, then a seventh compartment, then an eighth compartment, and so on. Let's just take another analogy here. We have 4 cherries given to us by default. 4 cherries. So this is the first one, this is the second one, third one, and the fourth one, right? Now I have a fifth and a sixth cherry too. I'd again need the static array to grow in size. The current size is 4 here, size equal to 4. So I need the static array to grow in size in a manner that it can accommodate these 2 new cherries as well. Let's just change the color here a bit, right? For this here, again, these two, let's just consider them phantom compartments that will handle our fifth and sixth cherry here. We need our array to grow in size. So what can we do here, right? Now, one way to do this will be to just, add one phantom compartment at the end of the array, right? So if we just add one phantom compartment, we'll be able to accommodate our fifth element in it, but the sixth one would still need some more space. So, okay, because we already know that we have two items here, we know that we can just add 2 compartments here. But in most cases, we might not actually know just how many elements we have by default. Sorry, by how many elements we might need to add to our array here, right? We just got lucky here that we know that we need only 2 elements, but if suppose you are storing student records in a school or university or whatever, the number of admissions in that school, the number of admissions in that term is not something fixed. It can range from just, any number. So it can just be between 1 to maybe 1,000. Just pick any number and that many number of phantom compartments we'll need to accommodate more admissions, right? And that's not a good way that we add one compartment per uh, per new data here, because it's just again more work. Now suppose I'm just going to draw this again here. So now this is our initial array, right? And we suppose we need to accommodate one new student, sorry, one we need to create one new phantom compartment here per new student we have, right? And suppose we have something like, I don't know, 100 such students, right? So I'll have to manually accommodate each student here. So suppose this has 1, this has 2, this has 3, this has 4, right? Then another student 5, then another student 6, then another student 7, then another student 8, and then so on. It's a bit tedious task, right? It's tedious for me, it's tedious for the computer as well. So in this case, can we just guess how many phantom compartments we might need in the future? We can't actually just guess anything here, right? We can just take something that can be called a guesstimate. That hey, let's just guesstimate that whatever the size of the initial array is, whatever the size of the current array is, sorry, not the initial array, whatever the size of current array is, I'll just double it each time I get a new element, right? So if I have two elements by default, two elements, this is my initial length. If I get a third element, I'll just double the size, right? 2x. So 4 elements. So now my array is of length 4. This way it can accommodate the third and the fourth element easily. Even though we don't have the fourth element yet, it can still accommodate it. We already have space. So whenever we get the fourth element, we won't actually have to create a compartment for it as it's already been created. We can just simply add it here. So 1, 2, 3, we firstly just don't have any need for the fourth compartment because we don't have any fourth element. But suppose we just get a fourth element after some time. We don't actually have to go ahead and create a new compartment for it. We can just simply add it here that, hey, I already have, you know, a compartment available for you. So you can just take that. Now suppose we have a fifth element, right? So for that, we can again just double the size again. Sorry, not 6, 8, x2. So I'd go ahead and create 4 more compartments. 1, 2, 3, 4, right? So here, if we have a fifth element, we can just accommodate it right in pretty easily. We still have 3 empty slots, 3 empty compartments for any future 6th to 8th elements, right? Now suppose these two get filled up with more elements, then we again have to increase the size by 2, x2, 16. So we just again have to create something like this. 1, 2, 3, 4, 5, 6, 7. I hope that's it. So 9, 10, 11, 12, 13, 14, 15, and 16, right? And then suppose we have another element coming here. So again, just 2x 32. So again, just copy this thing again, and we'll again have 32 more compartments, right? Sorry. So we'd again have 32 more. We'd again have 16 more compartments and 32 in total. Why are we doing this x2 again? This might seem like a pretty random thing that we are again doing here, right? So this is just something we are doing to exponentially decrease the time that is taken to create compartments. Now again, this might just sound pretty weird to you that, hey, Does it really matter that if I create a compartment each time I get a new element, or I just create n number of compartments, even though I don't actually get n number of elements? Like, let's take this n, let's take this one. So suppose you might be wondering that suppose if I have n number of elements, and if we add them one by one, we can just create compartments for them each time I get a new element. Why already create n number of compartments beforehand? That's just wastage of space. And you are correct on that. That space might go wasted there. But the reason we do this is because creating such a compartment is tedious. It takes time. And by just exponentially increasing the time between compartment creations, because first you create a compartment when the size is 2, then you create more at 4, then at 8, then at 16, then at 32, so on to the power n, where n is a natural number, right? You create compartments whenever your list has a length of 2 to the power n. This makes the whole compartment creation process a bit more, what can I say? It just delays out the compartment creation process so that uh, you won't have to do this again and again because you already have the number of compartments created beforehand. This will make more sense as we go ahead and discuss time complexity, time complexity of linked lists and vectors. Linked lists and vectors. There's a concept called asymptotic time, and then there's a concept of the big O of n. So these two are a big fundamental reason behind this exponential backoff that we are creating. This can be called as an exponential backoff. We need this exponential backoff to get a better time complexity because of these two things. Uh, I'm sorry if you're still confused about why we need to do 2x, but I hope you actually know why we need dynamic arrays. Again, because static arrays are pretty good, that if we already know that we need n number of items, but if we need an n plus 1 item, in this case a fourth item, we can just extend our previous array and add the fourth item into this. So that's all we have for dynamic arrays. Next up, we'll be discussing memory in C with the call stack and heap. And those are pretty big topics, and that'll probably be the most important video in the whole playlist. Like, these are important too, but this is the main theory, the biggest chunk there, and I'll thus it might require a little bit of effort on your hand too to just understand how these things work and remember how these things work and the needs for what we'll be doing ahead. So thank you for watching and I'll see you in the next one. Bye bye.